Hello, everyone. Mr. Minnick is my name, and math is my game. And on today, Chapter 8, Section 4, the title is Multiplying and Dividing Rational Expressions. And I got to be very honest with you. This is my favorite lesson to go over as far as the notes go because they're really easy. 2 words. That's it. 2 words. Everything else is just examples. The state of Ohio, the Common Core Content Standard is 10p6. You'll be able to solve equations that have rational expressions. You'll be able to describe and compare the characteristics of the following families of functions, quadratics with complex roots, blah, blah, blah. So you might say to yourself, why did we go from Chapter 5 to Chapter 8? And the answer to that's going to be pretty clear in a minute. So here's your notes. Factor, cancel. That's it. That's the notes. Factor and cancel. That's it. How do you do these? Factor and cancel. There might be one other thing that I'll need to add. So maybe it's not just 2 words. When you get to multiplying an expression by another expression, I don't know if you understand the way fraction multiplying works, but you just multiply right across the top. So all you're going to do when you do this is just make a big fraction. You're just going to make a big fraction. I'm not going to say what the A stands for. I think you already know. Sometimes you're going to be asked to divide. And when you divide, I don't know if you remember this or not, but you multiply by the reciprocal. So what you'll be doing then, when you do something like that, is again, you'll just make another big fraction. And what you'll be doing with this is kind of flipping it over. You'll just kind of flip that over and you'll multiply. So you'll see when we get to them. But probably if you can factor, and if you can cancel, and if you understand cross-canceling, this is going to be really easy. It should be really easy. Now, considering the fact that we factored in Chapter 4, Section 3, Chapter 4, Section 4, Chapter 5, Section 3, 4, and 5, you should be pros at factoring by now. So maybe we need to look at canceling. Some people say it has 1 L. Some people say it has 2 L's. I don't care how many L's it has. But canceling, if we had something like 3 times x plus 2 times x minus 8 all over x minus 2 times x minus 8 times 9. There are some things there that cancel, and there are some things there that don't. Anybody think they have an idea as to what cancels? What are we thinking? You might think that the x plus 2 and the x minus 2 cancel. In order for things to cross-cancel across that fraction bar, they have to be identical, both in the number of terms in each particular factor and the signs on every term for that particular factor. So the x plus 2 and the x minus 2, you might think they factor because of the same numbers, but actually, they're not going to cancel. What are we thinking? So the x minus 8 and the x minus 8, those are going to cancel, yeah, because those are identical. Those are going to cancel one another out. What else? The 3 and the 9. So if we had the 3 and the 9, because of the commutative property, because of that thing called the commutative property, we could bring this 9 out front, and we know that 3/9 reduces to how much? 1/3. So when we cross cancel, we say the 3 turns into a 1, the 9 turns into a 3, and you know I like to say the magical tractor turns into a field. So when the dust settles, you'll be asked to kind of rewrite your answer, and your answer is going to look like this. And this is where it gets really confusing, because a minute ago, when we said the x plus 2 and the x minus 2 cancel, when people look at this, let me bring great attention to this. When people look at this, what they see is, hey, there's a 2 and a 2, and we can cancel those. And there's an x and an x, and we can cancel those. The problem is the x and the 2 and the x and the 2 are separated. They're polynomials, and we can't cancel this. as much as you want to, this cannot be canceled or simplified any further. You can't do anything else with that. Now, if we had just had x over x, of course that's going to be 1. If we had 2 over negative 2, that's going to be negative 1. But the deal is, because we have separate terms here, because we have this term and this term and this term and this term, these two terms here make up a factor. Question. What happened to the 3? Oh, thank you. Good looking out. I'm so sorry. I should neck myself. I'm glad you said something about the 3. The 3 needs to be there still. Thank you. So the 3 belongs in the bottom. So I better put it, well, use the same color marker. The 3 needs to be there. Thank you. I almost forgot about the 3. Hashtag don't forget the 3. Cool beans. So do we kind of have an idea of the cross-canceling business? Okay, let me show you another example that's kind of tricky. This is the one that I put on my advanced classes test, and they've missed them both times. 2 plus x over x. Ooh. Now, if you understand the way fraction addition works, you might think to yourself, I could, you don't have to, but you could rewrite this as 2 over x plus x over x. Does that make sense? Because we have 2 divided by x, and to that we're adding x divided by x, right? So if we did that, the 2 over x isn't going to change, but the x over x, what could we make that since we're dividing something by itself? Yeah. It is 1. No, you're right. It's 1. Something divided by itself is 1. Okay? A quantity divided by itself equals 1. Okay? So when everything cancels, what's left is a 1. That's going to show up. On some of these exercises, there's going to be a lot of factors, and everything's going to cancel, and you're going to say, well, nothing's left. Well, yeah, there is something left, because you're dividing a quantity by itself, and when you divide something by itself, it equals 1. Now, there's really only one caveat to this, and the caveat, the reason that I started toward the end of Chapter 8 rather than beginning of Chapter 8, I don't think we're ready to look at the graphs just yet, but I want you to, I'll show you a sneak peek of a graph of one of these things. If we graph that, when we graph it, it's going to be a wild looking graph. It's going to look like this. It's going to have branches like this and like this. And there's going to be this imaginary line that the graph doesn't go through here, and an imaginary line that the graph doesn't go through there. And those lines have a special name. It's not important yet what they are. But the deal is, if you think about this, the domain of this is that we go from negative infinity to 0, and then on the other side of that, we pick up again and we go from 0 to infinity. But x can't equal 0. Can somebody explain to me why x can't equal 0? Because the axes are, well, there's a line there. It's actually called an asymptote. Yeah, because of the graph, that's part of it. But mathematically, there's some math fact that Siri actually knows about. I think Bixby does too. Anybody see what I'm looking at here? Let me ask Siri. Not Siri. I don't have Siri. I don't have any stuff. Let me ask Bixby. Hopefully Bixby doesn't let me down. Bixby, what's 0? Let's try that again. Scratch that. Bixby, what's 1 divided by 0? I think I just broke Bixby. Can anybody tell me what 1 divided by 0 is? It's not 0. What did you say? It's not imaginary. What? It's not 1. Think about vertical lines. What do you know about the slope of a vertical line? It's undefined, and so is division by 0. Okay? Really big idea in mathematics is that division by 0 is undefined. So what ends up happening on a graph like this is x can't equal 0, and actually x and y can switch places here, so y can't equal 0 either on one of these graphs. If you look at the range, it's kind of the same thing. So the deal is, if you have something like this, if you have something like 2x plus 5 over 2x plus 5, and you graph that, this is so cool what happens. This is where the calculator is actually going to lie to you. What does that expression simplify to be? That expression simplifies to equal 1. Now, I'd bet a lot of money, even though you're not allowed to bet in school, but I'll bet that most of you could graph the equation y equals 1. What's the slope of it? 0. So it's going to be what kind of line? Is it a vertical line or a horizontal line? Horizontal line. So basically, we're just going to have a horizontal line and when y equals 1. So it's just going to be like this, right? But there's one catch to it. You're not allowed to divide by 0, right? You're not allowed to divide by 0. So 2x plus 5 is not allowed to equal 0. So that means 2x couldn't equal negative 5. That means x couldn't equal negative 5 halves. What that means is right here when x is negative 2.5, that graph has, here's a fancy word to say hole. So if you ever need a fancy word to say pothole, you could say pot removable discontinuity. In chapter 8, section 1, we're going to call these things removable discontinuities. In mathematics, it's a hole, but it's also called a removable discontinuity. A removable discontinuity. That's chapter 8, section 1. We'll talk about that again. Could you imagine going into the shop? What's the matter with your car? Oh, I hit a pot removable discontinuity. What the heck are you talking about? Just to show you what I'm talking about here, I'm going to go ahead and open up my calculator, and I'll show you that the calculator will actually fail you on these. The calculator will let you down. It will not show you the whole. Maybe my old school calculator will. It's going to take a minute for my Inspire to load. But my TI-83, if I graph this y equals 2x plus 5, 2x plus 5, the quantity divided by the same quantity, divided by 2x plus 5. Go ahead and graph it. So there it is. But I don't see the hole in that, so let me change my window. Let me go from -3 to -2, and on my y scale I'll go from 0 to 2, and that'll give me a better picture of it. Do you see right in the middle how there's a hole? Do you see that? So if I calculate a value whenever x is 2.5, I said whenever x is 2.5, I get an error. If I go to the table, and I were to set my table up so I could start at a half I'll start at 1 and go by halves. So if I look what happens when x is 2.5, well, it should be -2.5. Go back into the table. When x is -2.5, do you see how there's an error? You see that? Okay. Cool. So in the meantime, this other calculator is loaded, so I'll go ahead and graph this here. And this is where I got to be honest, I don't like the Inspire. I'm using the CAS today, and there's a good reason for that. So our function was 2x plus 5 over itself over 2x plus 5. And so when we graph that, it looks like the line we talked about. Let's change our window. Same window as before. We'll go from -3 to -2. And then we'll go from 0 to 2. This one doesn't show the hole, does it? So if I go menu, trace, graph trace, I guess it does show me that if I do a menu trace graph trace. Just happened to land on that point. X is -2.5 and Y is undefined. But anyway, so that's the one caveat. The caveat to look for is that division by 0 is undefined. So at some point, they're going to give you something like this. And here's a real easy example. Example 0, simplify. Simplify. X squared minus 25 divided by x plus 5. But they're not only going to say simplify, they're going to say simplify and state any restrictions. And state any restrictions. So this and state any restrictions, what that means is you need to set the denominator equal to 0 and solve. And the real solutions are the restrictions. The real solutions are the restrictions. So if they ask you, simplify and state any restrictions, you're going to factor, you're going to cancel. And you're going to have to set the denominator equal to 0 and solve, and the real solutions are the restrictions. So before I even try to simplify this, I'm going to go ahead and state my restrictions now. I'm going to go ahead and do this part now. Restrictions. Anybody think they know what it is? -5. What about -5? So when we looked at this one, we said x can't equal 0, right? So when we look at this one, we're going to say, what about -5? That x can't equal that. Does that make sense? So technically, we should set the denominator not equal to 0, I guess, right? Because the denominator can't equal 0. Okay, so set the denominator not equal to 0 and solve. And the real solutions are the restrictions. Okay. So who recognizes the numerator and how we can do something to that? Anybody know what we should be able to do that? Not take the square root. It factors into x plus and minus 5. Yeah, that numerator factors into x plus 5 and x minus 5. The denominator is still x plus 5. So now, at this point in time, we're looking at this expression. So what can we do with that expression? Cancel what? The x plus 5s? Okay. So we cancel the x plus 5 with the x plus 5. So our final answer is going to be what? X minus 5. What do you think? Seem pretty easy? That's more or less what we're going to do. That's what we're going to be doing. Ready for example 1? All right. Example number 1. Simplify. Quadratic over a quadratic. So the title, they're talking about rational expressions. What a rational expression is, it's a polynomial divided by another polynomial. So chapter 8, we're going to be dealing with polynomials, and that's why we went right from chapter 5 to chapter 8. But instead of just having a polynomial, we're going to have them set up in fraction form. So we ought to be able to factor that numerator, I hope, and also the denominator. Does 15 have any factors that add up to -2? 5 and 3, okay, so x and 5, x and 3. Got to get our signs right. -5 plus 3, okay. And on the bottom, what's going to happen down there? X plus 3 and x minus 3. So do we have anything that cancels? The x plus 3 cancels out the x plus 3. So our answer is that, what do we got? The quantity of x minus 5 over the quantity of x minus 3. Now, can we cancel the x's? No. Remember, because it's an x minus 5, we can't cancel the x's like that. Okay, don't think you can, because you can't. So that's it. That's it. So I got out the TI Inspire CAS earlier. Did you notice that? I'll show you something about the TI Inspire CAS. CAS, by the way, stands for Computer Algebra System. So if you punch in one of those expressions, just like we had there, this calculator is going to do its very best, and it's really good at doing stuff. It's going to do its very best to simplify that expression. And what's going to happen is it's going to have an exclamation point, and that exclamation point means, there's probably something else going on here that I can't say because I'm a calculator. Do you see how there's an exclamation point on the left side of the screen? It says, I did stuff right. But your teacher's probably going to ask you for something more. Like, what are the restrictions? What are the restrictions? What are the restrictions? There's more than that. If you were asked for the restrictions, you need to go all the way back to the beginning. Not just at the final product or result, but you need to go back and look at the beginning, the denominator of the beginning, the denominator of the beginning. What are our restrictions? X can't equal negative 3's, or 3's right, but also because of this factor right here, x can't equal 3. That's true. But because of this factor right here, what else can't x equal? Negative 3. X can't equal negative 3 also. Okay, so how about plus or minus 3? X can't equal plus or minus 3. Question. To find the restrictions, what you do is you take the denominator, right from where you start. You take that denominator, x squared minus 9, set it not equal to 0. And that gives you your restrictions. X squared can't equal 9. You take a square root. X can't equal plus or minus 3. That's it. You just take the denominator, set it not equal to 0, and that's it. Okay? And again, you got to go back to the beginning. Sometimes you need to look at it at every step along the way, especially when you get into fractions. There's a little tricky one there. With the fraction one, well, when we get to it, I'll try to remember to look at that. It's a good question. Any other questions before we move on to the next example? Okay. Example 2 then. Actually, we'll go to example guided practice. Out of these, 1, 2, 3, 4, 5, and 6, any in particular that we better look at? 6? Yeah, let's look at 6. So we'll look at 6 here. So one thing about these is, anybody in here play baseball or softball? You ever steal a base? When you steal a base, you kind of have to cheat a little bit. Now, I'm not endorsing or encouraging cheating, but what I am trying to tell you is, chances are, when you do this, there's going to be some factor here that's going to cancel out some other factor. Does that make sense? So maybe you're horrible at factoring, but you're good at factoring out a GCF. Because up top, you can factor out a 2x, which means you're going to have an x plus 5, right? So if I had to take a wild guess as to how this factors, I would bet my paycheck that one of the factors of that is going to be x plus 5. I might be wrong, and I might be without a paycheck. But the idea in this section is that things are probably going to cancel. So I'm going to go on record and make this assumption. I haven't worked this problem out yet. I'm going to make this assumption that those are going to cancel. So let's see. Even though I suck at factoring, 5's other factor that adds up to 5. Well, let's see. It's 3x and 5. I guess this has got to be a 1, right? And this has got to be a 3x. And everything's positive, so it's got to be a 1. Dude, would you look at that? That's it, isn't it? So even though I don't like to factor that quadratic where a is not 1, even though I might, not be good at factoring something like that, I can guess. I can kind of lead off the base a few feet. So what's the answer end up being on this one then? 2x divided by 3x plus 1. Nice. There it is. 2x over 3x plus 1. Can you cancel out this x with this x? No, you can't. In the restrictions, so with the restrictions, you got to look at the denominator. You got to set the denominator. Maybe that's hard to work with. You got to set the denominators not equal to 0. So our restrictions, 3x plus 1 can't equal 0. X plus 5 can't equal 0. So x can't equal negative a third, and x can't equal negative 5. Those are our restrictions. Okay. How do you do this section? Factor cancel. What about the restrictions? Set the denominator not equal to 0 and solve. We ready to see some multiplying ones with the big fractions? Maybe we need to look at an example with just some numbers and variables multiplied, because there's a couple like that. I think the next example will have something like that. Yeah, check this one out. So on something like this, remember, make a big fraction. 8 times, hopefully you remember your exponent rules, x to the third times x to the fourth. X to the third times x to the fourth, that's going to make what in the numerator? X to the 7th, good. And then y times y cubed is going to make what? Y to the 4th in the numerator. And then I still got this times 7 up there. This is all over. What's 2 times 4? 8. And I'm in the bottom, I got just an x to the first power. And I got a y squared times a y. What's that going to give me? Y to the third. So now if we look at this expression right here, does anything cancel here? Some of the x's are going to cancel some of the x's. If you remember your exponent rules across the fraction bar, what do you do with the exponents? Subtract them. So we're going to end up with x to the what in the numerator or denominator? X to the 6th in the numerator. Okay. Let's move on to the y's. What are we going to have with the y's? Y to the first up top or in the bottom? Up top. Anything else cancel? The 8's cancel. What's left? 7, and that goes in the top. And so on this one, the right answer, I guess, is a bee's in the trap. Gonna have to listen to that song now. I won't be the same afterward either, no pun intended. Sure. So with one like this, just kind of take them one item at a time. Look at all the numbers. 8 times 7 is 56. 56 divided by 8 is going to give you 7. So right off the bat, you can eliminate choice A. And then look at your x's. X to the third times x to the fourth is x to the 7th over x. So that gives you x to the 6th. And just when you do that much, you get down to the right answer pretty quick. I don't know why, but on the quiz, when my advanced class took the quiz, they really struggled with these ones. Maybe because we hadn't covered our exponent rules before. I don't know. But we covered exponent rules in here, I know, a couple of weeks ago. All right, well, time for some big fractions. Remember, we're just going to make some big fractions. Um, I want to look at this part here first. X squared plus x plus 20. Can we factor that? What's that going to factor into? X and an x. 20's factors that add up to 4 and 5. And the signs are going to have to be what to make it a plus x? Positive on the 5, good, and a negative on the 4, awesome. So the denominator, this is going to factor also. And again, a lot of times we know that there's going to be like factors that are going to cancel. So again, I would bet my paycheck that it's going to be x plus 5 and x something. So it's x plus 5 and then what? Got to be a 1. What about the sign? Minus a 1. So the x plus 5 is going to cancel out the x plus 5, right? And there's, of course, that 3x in the denominator. This 3x is going to be there. So I'm really glad that whoever came up with this example, I'm really, really, truly glad that they have this. This is one of those things that math teachers, especially in college, they like to throw out at you. If you wanted to factor out a GCF, we could. Anybody see what it is? 3x. So let's go ahead and factor out that 3x then. So that's going to be 3x times what? 1 minus x. Good, good. So is there anything else that cancels? The 3x's now cancel. So this 3x here cancels out this 3x here. So we think we might be done. So we got 1 minus x times x minus 4, and that's all over x minus 1. Now here's where pre-calculus students get in trouble. Here's where Algebra II students get in trouble. They look at these. And they ask themselves, well, can I cancel that? Technically, you can't, as they are. You really can't cancel those as they are. But what you can do is you can rewrite this. You can rewrite that. If I put the x term out front and I factored out a negative, that would be negative the quantity of x. And if I factored out a negative, it's going to change the sign of the 1, isn't it? And it's going to make it a minus 1. Does that make sense? Okay. So that's still times x minus 4. Now this is all over x minus 1. Now can I cancel anything? Now the x minus 1s are identical factors, and now those can cancel. So what's left then is negative the quantity of x minus 4. Maybe you love the distributive property and you just have to distribute. If that's the case, go ahead and use the distributive property. So this would be negative x plus 4, right? As far as your restrictions go, you'd have to look all the way along the way. I'm not going to write them down here, but x could I can't get it out. My mouth's all dry. X could not equal 1. X could not equal 5, negative 5, I'm sorry. And x also can't equal 0. Those are the restrictions. X can't equal 0, x can't equal negative 5, and x can't equal 1. How are we doing so far? Okay. Any big questions before we look at our division example? Is the 0 because it's not factored out? So when we're looking at the restrictions, when we get to right here, if we look at the factored form, that's probably the best way to look at the restrictions. That tells us x can't equal 1. This tells us x can't equal negative 5. This is where the 0 comes from. Yeah, from the 3x. Because of this, 3x can't equal 0, and that's where x can't equal 0 comes from. Okay. Any other questions before we look at the last one? Or the last idea? Okay. All right. Oh! Example 5. We want to do this one real quick? What a trip down memory lane. So this numerator is x plus 2. The denominator's got x cubed minus 27 in it. Now that's a difference of 2 cubes, which we studied in chapter 5. And the way it factors is a binomial times a trinomial, and the signs are going to be minus plus plus. And I take the cube root of x cubed, which is x, and I take the cube root of 27, which is 3. Going to here, I square the first term. Going to here, I square the second term. And in the middle, I just multiply these two things. Now, somebody's probably looking at that x squared plus 3x plus 9 and thinking, I can factor that. Well, no, you can't. It doesn't factor. It never has and it never will. One thing about these difference of cubes, I had said it before, and it's worth noting, the binomial portion of these difference of cubes, or sum of cubes, that part's not going to factor, but that's okay. Even though that doesn't factor, it's okay. So we got this hanging out in the numerator. And it doesn't matter that it doesn't factor. We could still cancel those common factors, can't we? So this x squared plus 3x plus 9 is going to cancel this x squared plus 3x plus 9. And so our answer is x plus 2 over x minus 3. Cool beans. And on this one, and we'll talk more tomorrow about why, but the only restriction is that x can't equal 3. The reason that's the case is if you were to take x squared plus 3x plus 9 and set that equal to 0 or not equal to 0 and solve, you're going to get imaginary answers. And earlier we said with the restrictions, a long time ago, we said you set the denominator not equal to 0 and it's the real solutions. If you get imaginary ones, that doesn't affect your restrictions. So we're running low on time and we got one last one to look at. When you divide. So whenever you divide, you're going to leave the first fraction alone, the 7x, 2 times x minus 5. And when you divide by a fraction, it's the same thing as multiplying. And so here's where a big fraction comes into play. Just make a big fraction. It's the same thing as multiplying by the reciprocal. So I'm going to be flipping or inverting this. So I'm going to go ahead and factor this denominator, but that's going to go up to the numerator. So that's going to be x minus 5 and x minus 6. I'm going to go ahead and factor this numerator, but it's going down to the denominator. So that's going to be x times x minus 6. Oh my. X minus 5 cancels x minus 5. X minus 6 cancels x minus 6. Anything else cancel here? The x with the x. So the x will cancel out the x. So what's left? 7 over 2. That's it. It's been real. It's been fun. I hope it's been real fun and educational. Tonight's exercises, I want you to at least try them, okay? You might not get the right answer, and I don't want you to go to Mathway. It's one thing to get the answer. It's another thing to get the answer on your own merit, okay? So I hope everybody has a good night. See you. Good.